Right then, so in today's lesson we're going to do a bit of practice of some of the probability topics we've looked at over the last, just before half term actually. So just have a read of these instructions. You need to have a pen and paper on you and be ready to take notes. You'll be asked to pause the video at certain points to attempt exercises, and also please watch all the video and don't skip bits, okay? Now this is the starter to have a go at. So you'll see 4 sections. In the top left section there is a frequency tree. And you need to answer those questions about that frequency tree. In the top right, there's a question on relative frequency, which is what we looked at previously in the last lesson. And then there's also a probability tree, which is different to a frequency tree, in the bottom right. And there's a different question at the bottom left as well. So have a go at those, put me on pause for about 5 minutes, and then come back for the answers. Thank you. Right, then the answers. So first of all, how many lions were there? Well, there were 3 lions in total. Looking at the tree, you see in the cat branch there's 3 lions. How many dogs were there? Well, there's 3 dogs as well, because you can see that written there. And there were 10 animals in total, because that's what's at the left-hand side of the tree. Now, as for the relative frequency, notice that all of these probabilities must add up to make 1. Okay, so you've got 0.38, you've got 0.24, so in order to make 1, you need to have another 0.38, so that's what the answer will be. Now, for the bottom left question, if Tom has 12 different cards, he gives one to Harry, one to Lewis. So he's got 12 choices for the first card, which he gives to Harry, so Harry could have any of the first 12. And then once a card has been given to Harry, that means there's only 11 choices left. So that's the reason why I've got 12 and 11 written down there. So it's 12 times 11. Now, as for the probability tree, the point is these probabilities must make 1 in total. So if it's 2/3 or more than 2, then it must be 1/3 for 2 or less, because these 2 add up to make 1. We're going to practice this in the next part of the lesson anyway. And then also on the second dice as well, in the same idea. And you want to have the probability that both dice land on a number more than 2. So the first dice being more than 2 is going to be 2/3, and the second dice being more than 2 is also going to be 2/3. So you multiply those 2 numbers together, 2/3 times 2/3 times the top times the bottom, you get 4/9. So as I said, we're doing a bit of revision today. So this is sort of a bit of a guide of what we're going to do today and what we're going to do tomorrow. So today we're going to look at frequency trees and also tree diagrams. So 2 of the things that were on the starter, the top left and the bottom right, and also experimental probability as well, which was in the top right as well. So depending where you're up to with the starter, there's going to be more practice in the following part of the lesson. So frequency trees. So let's just go for an example together then. So 30 students were surveyed about their hair. There were 14 male students and 16 female students. 8 male students had blonde hair, 9 female students had blonde hair. How many male students didn't have blonde hair? Well, that's quite a complicated looking question until you put it into a tree, and that makes it much simpler to answer. So first of all, we start with the 30 people, and then the next sensible split is going to be male or female. So there are, from the question, 14 male students, so that means there also must be 16. Notice how 14 plus 16 makes 30. Now we're going to do the separation to blonde hair and not blonde hair. So how many male students had blonde hair? Well, from the question, that's 8. So how many didn't have blonde hair? So let's give you a second to think about that. Well, that's got to be 6, because you can see 8, you've got to make 14. It's got to be 6 in that box there. And then in the female box, blonde and not blonde, so it says 9 have blonde hair. Again, we've got to make this to be 16. So it's got to be 7 in the bottom box. So notice all you're doing is making these branches add up to the number that it is before. And then now we can answer the question. So how many male students didn't have blonde hair? So where are we looking on this? So looking at male students, first of all, and then not blonde hair. So that's going to be the 6 here. So it's going to be 6 is your answer. Right, then there's one for you to try. So what I want you to do is draw the tree out. So that's what the tree will look like. And I want you to fill out the tree first of all, and then answer the questions associated with it. So about 3 minutes to try this question, and then come back for the answers after that. Thank you. Do you want to put me on pause? Right, so going through the answers. So 27 male students studied drama. And then it also says 47 in total studied drama. So that means that's got to be 20, so you make 47. Now it says there were 55 females. That's what goes in next. And then we've got to have 45 males, because you've got to make 100. And now it's a case of filling out the rest. So to work out this box here, it's going to be 27 add something to make 45. Well, that's 18. And then it's going to be 20 plus something to make 55, which is 35. Right, now, how many male students didn't study drama? We look at male and not drama, so it's going to be 18. That's the first question. Now, it also says, if you pick a random student, what is the probability that they are a female student who doesn't study drama? So female and not drama is 35, but remember, probability means it's got to be written as a fraction, so you write it out of the total, and the total is 100, so it's 35 over 100, and that's your answer. Okay, so hopefully you're feeling a bit more confident about that now, once you've tried it yourself. So again, there's another one for you to try here. So fill this tree out, and then come back for the answers once you've filled that out. Okay, so I'm just going to reveal the answers. Just check you've got that right. And now we're going to answer some questions about this tree. If you've not got that, make sure you're referring to mine that's on here. So how many girls like coffee? Well, girls that like coffee are going to be, it's going to be girls, and it's going to be like coffee, it's going to be 8. How many boys like coffee? Sorry, how many boys don't like coffee? If you go down the boys branch, and it's don't like coffee, it's going to be 4. It's following the route through the map. And then finally, what percentage of boys don't like coffee? So so you can see that 4 boys don't like coffee. And there are 10 boys to begin with. So it's 4 out of 10. Now 4 out of 10, you can just type 4 divided by 10 in your calculator, which gives you 0.4, which is the same as 40%. Okay, there are 2 questions here to try. I don't know why the number 1, 2, 3 have appeared on there, because there are only 2 questions. So have I got those 2 questions? Once you've done enough of those, come back for the answers in about 5 minutes' time. Thank you. Right, so here are the answers. Do you want to mark them? Notice I've got 5 for the question here, and then 10 for the other question here. Right, so that's frequency trees. But now we look at tree diagrams, which are slightly different, but the idea is the same. So let's read the question together. So Rebecca has 9 coloured beads in a bag. 4 of the beads are black and the rest are green. She takes a bead out from the bag, notes the colour and puts it back. And then she does the same for a second bead. Now we're going to draw a probability tree. And this is kind of like, if you remember the starter, it's the bottom right section. Right. The first choice that Rebecca has is black or green. There's only black and green ones in the bag. So there's 9 in total. You can see that it says 9, and 4 of them are black. So what is the probability of getting a black bead? Well, it's 4 out of 9. So therefore, what's the probability of getting a green bead? Well, it's going to be 5 out of 9, because you can see you've got to make 9. 4 and 5 is 9. Right, and then she puts the bead back, and she does the same thing again. So let's do another branch now. The second choice. Again, it's just, you can only get black or green. So again, the probability is exactly the same. 4 out of 9, 5 out of 9. 4 out of 9, 5 out of 9. So these are different from tree diagrams because we're putting probabilities on the branches, not the frequency. Right, then now to work out the probabilities, you multiply along the branches. So the first one is going to be 4 over 9 times 4 over 9, which is just times the top times the bottom. 16 over 81. Same again. Times the top times the bottom. It's 4 over 9 times 5 over 9. You can do all the other ones in the same way. Now we can answer the questions. So the steps are draw the tree, write down the probabilities, and then you can answer the questions. So I want 2 green beads. Well, two green beads is the bottom branch, green and then green. So it's 25 out of 81. And the second question is then a black bead followed by a green bead. It's black, then green, which is 20 out of 81. Okay, so have I got this one then? So I will start by putting some of the tree down for you. Okay, so fill out the rest of the tree. So probability it's sunny on Saturday is 3 over 7, so you can say I put 3 over 7 and then 4 over 7, so you've got to make a whole one. So now I'm going to put the 2/5 on the second on Sunday, and then you're going to fill out the rest of the branches, and then remember to calculate your probabilities, you multiply. So work out the probabilities for me, and then answer the question. And put me on pause till you've had a go at that. Thank you. Okay, then so filling the rest out. 2/5 it's sunny on Sunday, so it's going to be 3/5 it's not sunny, and the bottom branches are the same. And again, you're just multiplying out the branches. So work them all out by multiplying. So you're just doing 3/7 times 2/5 to the top one. Multiply the top, 3 times 2 is 6. Multiply the bottom, 7 times 5 is 35. Same idea for all the other ones. And you work your way through. So the second one will be 3/7 times 3/5. Right, not sunny all weekend. So we want not sunny on Saturday, not sunny on Sunday. So it's the bottom branch. So it's 12 out of 35. Okay then, so have I got this one? Same again. So this time it's an exam question. So draw the tree out for me. I only want the branch at the top up here this time, so fill out the probability here, fill it out down here, and then fill out the probabilities at the top up here as well. So one's coming from the spinner, being even or odd, and then one's coming from the dice, being red or green. Okay, so have I got that, and then come back for the answer once you've tried it. Thank you. Right, let's have a look then. So it says, right, first of all, a fair spinner has 5 equal sections, 1, 2, 3, 4, 5. So when it's spun, right, so you want to work out that it's even first of all. The chance of it being even, there are only 2 even numbers, so it's 2/5. That means the other one must be 3/5. Now the chance that it's red is going to be 5, 6, because a dice being red, it's got 5 red faces, so it's 5 out of 6. There's 6 faces in total, and that means green is going to be 1, 6. It's quite a hard question, this one, to fill out. So to repeat, the spinner is going to be 2/5 it's even because there are 2 numbers out of 5, and then 3/5 it's odd because there are 3 numbers out of 5. And same for the dice, it's going to be 5, 6 for red, and then 1, 6 for green. Because there's 5 red and 1 green face. And you want the probability of getting an even number and the colour green. So even and then green. So it's 2/5 times a sixth, which gives you 2 over 30. That was quite a tricky question. Okay, so what I want you to do now, you can do exactly the same thing for decimals. So I want you to try this question, fill out the rest of the tree. Remember the probabilities on these branches here must equal 1. So if that's 0.3, you've got to make 1, so it's got to be 0.7 on the first one. And then fill out the rest of the numbers, and then you multiply in the same way. You can use a calculator. So have a go at that, and then come back to the answers once you've done. Okay then. So there's also another question there for you to answer as well once you've tried that. So in fact, let's go for the answers first of all. On this, you should have 0.7, 0.2, 0.8. You fill in the gaps, and then you've got to answer a question now. So you can fill out all the branches there. So you're doing multiplying, so it's 0.3 times 0.2 for the top branch, and you multiply out the rest. And the question is, what's the probability that she has to stop exactly once? Right. So it's stop or don't stop. So stop once, either the first one stop and then she doesn't, or then it's going to be doesn't, or, right. If it's going to be stop exactly once, means that one of the lights is a stop and one of them is a doesn't stop, or it's a doesn't stop, then a stop. So this branch here, stop, and then doesn't stop corresponds to one stop, so it's 0.24. And you've also got doesn't stop and stop, which corresponds to 0.14. So you add them together. And you see there are two possibilities for don't stop and then stop. So you add them. 0.38. Right, okay. So what we'll do is we will stop there for today. So I'm going to skip past this. We'll do this relative frequency tomorrow. Oops, apologies about that. So please can you just red, amber, green, purple your work. And then that is the end of the lesson. Thank you for listening.